Okay guys, in today's lesson is identify function using sets of ordered pairs, tables, mappings, and graphs. I, to me this lesson is pretty fairly easy, so hopefully I don't go too quickly, but please follow along. Let's first look at some definitions. It says a relation is a set of ordered pairs x comma y where the x is associated with a specific y. So it's just as long as you have some ordered pairs, then you have a relation. Now a function is a relation in which each element of the input, x, is paired with exactly one element of the output, y. All functions are relations, but not all relations are functions. So pretty much what that a function is it's pretty much saying for every x value or every independent value, I'm going to be paired with exactly one and only one y value, aka dependent value. Let's look at some examples here. So here's some ordered pairs. Let me get my pen out. Okay. So example of a relation that is a function. So for example, they have some of these ordered pairs: 5 comma 4, negative 2 comma 6, 0 comma 5, and 1 comma 3. Over here on this other side, they have an example of a relation that is not a function. So they have the ordered pairs 4 comma 3, 1 comma 5, 2 comma negative 2, and 1 comma negative 2. You may be asking, why is one a function, the other one not a function? And you may have already seen the difference and caught on. But for example, this guy on the left side is a function because the domain member, or the x value 5, coordinates with the value 4. The negative 2 coordinates with 6. 0 goes with 5. And 1 goes with 3. So each domain member, or each x value, goes with only exactly one and only one y value. Well, look at this other guy. We have 4 goes with 3. 1 goes with 5. 2 goes with negative 2. And 1 goes with negative 2. So we have 1 going with 5 and 1 going with negative 2. Can't have that happen for it to be a function. So therefore, that's the reason why this guy is not a function, because the domain member, or the x value 1, goes to two different y values, 5 and negative 2. Okay. Usually what I tell everybody is if you notice, and it's not always the case because they might try to trick you up, but if you notice the x value repeats, then you know it's not a function. Okay, this one is some tables. It's just like having ordered pairs. It's a 1 comma 4, 2 comma 3, and negative 2 comma 3. Once again, you can see each x value goes with exactly one y value. 2 goes with 3, and negative 2 goes with 3. That's fine. The x value 2 is associated with 3, and the x value negative 2 is associated with 3. Once again, each x value goes with exactly only one y value, which is great. It does not matter that the y values repeat. You can have multiple y values, for example here they have 3 going to 2 and negative 2. That's fine. It's the other way around, where the x value can only go with one specific y value. Here we can see the order pairs negative 1 comma 1, or I'm sorry, negative 1 negative 1, negative 2 comma 3, and negative 2 comma 4 if we write these in order pairs. Well, we got an issue here. Negative 2 goes with 3, but they're also saying negative 2 goes with 4. Once again, we cannot have a domain member, or x value, go to two different y values. In this case, it goes to 3 and 4. Therefore, he is not a function. He is a relation, but not a function. What about in these mapping diagrams? We got an example of a relation that is a function. Okay, of course, because 5 goes to 3. That's fine. 2 goes to 4, and negative 1 goes to 4. Once again, each one of my x values goes to one and only one y value. Okay, pretty much does not repeat. However, the problem with this other guy on the right hand side, the reason why he's not a function is because 5 goes with 3, but 2, my domain member 2, goes with 4 and goes with 5. Cannot have that happen. Once again, it's kind of like saying the order pairs 5 comma 3, and we got 2 comma 4 and 2 comma 5. Once again, the x member can only go to one y value. If you were looking at graphs and functions, we do with this thing called a vertical line test. And what it means is I can draw an infinite amount of vertical lines, and as long as I only hit my graph or once and only once, then it's good. And no matter where I draw these vertical lines, I only hit it once, or these dots once. And sometimes you can have like a, dots, or you can even have a graph, a straight line, or a parabola or something. But once again, I can draw this infinite amount of vertical lines and I only hit it once. The reason why this guy fails over here is because, once again, if we draw this vertical line right here, where it's indicated with this red arrow, we can see that we hit the graph twice right there. And the reason is kind of the same thing. If we had put these points down, we'd have 2, 3. If we put ordered pairs here. And another one, we'd have 2, 2, 2 would be correct. And 1, 2, 3, 4, 5, 2, 5. So you can see once again, we have the domain member 2 and it goes to 2 different y values, 2 and 5. Cannot have that happen. Hoping that's kind of clearing it up. We've got a couple more graphs here. That's a function. Once again, easiest to do a vertical line test. Once again, vertical line up and down. Only hit it once. Only hit it once. No matter where I draw the vertical line, I'm only going to hit my graph once. Over here on the right hand side, we have a circle graph. And you can see though, if we draw a vertical line here, we hit the graph twice. And if we hit it 2 or more times, it is not a function. Even if we do it right here, we'd hit it twice. So it cannot be a function. Anywhere kind of we draw this line, we hit it twice. So he is not a function. Kind of the same thing here once again. Vertical line, of course, on the right hand side they have a vertical line, and if you draw a vertical line on a vertical line, it's going to hit everywhere. So of course he's not a function. Alright, let's look at some problems here. It says, which set of order pairs does not show y as a function of x? So once again, let's look at our domain members. We got 3 goes to -2. It's good. 5 goes to -3. 7 goes to -4. 9 goes to -5. Once again, it's like our x value didn't even repeat, so this guy is a function. So he's a function. And we're looking for the guy that's not a function. 3 goes to -2. That's good. 6 goes to -2. Good. 9 goes to -2. 12 goes to -2. Once again, each one of our x values goes to a y value. And that's good. I mean, it does not matter that the y value keeps repeating. We just notice that our x value goes to one and only one y value. So this guy's a function. We got 4 going to -2, 5 going to -3, 6 going to -4, and 7 going to -5. Once again, good. Each domain member or each x value goes to one and only one y value. 4 goes to -2, 5 goes to -3. Oh, 4 also goes to -8. That's our problem. Our domain member 4 is saying it's going to both -2 and -8. So this guy is not the function, which is what we're looking for. Moving on to the next problem. It says a set of ordered pairs represents a relationship between x and y. Which statement about the set of ordered pairs is true? Our different answer choices are: the relationship represents y as a function of x, the relationship does not represent y as a function of x, the relationship represents y as a function of x, or the relationship does not represent y as a function of x. So we can eliminate 2 answer choices real quick if we can just determine if this is a function or not a function. Let's see here. Our domain member 2/5 goes to the range member 3. That's fine. 0.4 goes to 4. That's okay. 4/5 goes to 5. And 0.8 goes to 4. Well, they're trying to be tricky here. They're trying to make you think that each domain member only goes to one range member or one y value. But the problem is 2/5 is the same thing as 0.4. And also notice 4/5 is the same thing as 0.8. So our domain member 4/5 over here and technically 4/5 over here goes to 2 different range members, 5 and 4. Same with our 2/5. Same thing as 0.4 or 2/5 again. Goes to 2 different range members, 3 and 4. So this guy is not a function. So we can eliminate We can eliminate answer choices F, where it says relationship represents Y as a function. He's gone. And H. Okay, let's look at the difference between G and J. It says the relationship does not represent Y as a function of X because at least one X value is associated with more than one Y value. Or the relationship does not represent Y as a function of X because one Y value is associated with two X values. Well, this one is just, we got to remember the definition. Once again, if it's not a function, it's because at least one of our X values is associated with more than one Y value. So G would be the correct answer choice. Once again, J is not correct because it does not matter if my Y value goes to 100 different X values. It's fine. It's about the X value. Alright, we've got a couple of tables, kind of the same thing with ordered pairs, just kind of written differently. I mean, for example, I'm going to go and write this table out. If I were to write this table out in ordered pairs, we have 1, 6. Let's get 1, 6. And we have 2, 7. We got that from here. If you're used to tables, then this shouldn't be too hard. 1, 8. And 2, 1. And I'm not going to do this for all of them, but I'm just showing you that this is how you would write it out in ordered pair format. This is just table format. But I notice here 1 goes to 6, and 1 also goes to 8. Once again, that's a problem. So this guy is not a function. We got 1, 7, 2, 11, 2, 1. Once again, my domain member 2 goes to two different Y values, so he's not a function. Let's look at H. 1 goes to 3, 2 goes to 3, 3 goes to 3, 4 goes to 3, and 5 goes to 3. Once again, that's fine. Kind of trying to trick you up, but each domain member that we have here, 1 just goes to 3, 2 just goes to 3, 3 just goes to 3, 4 just goes to 3, and 5 goes to 3. Once again, it does not matter if the Y repeats. It's about the X repeating. J, well, we can see X repeats like crazy, so of course he's not a function. Okay. Got a mapping diagram this time. The same thing once again. It's just like ordered pairs. We got one. If you look at I, we got 1 goes to 1, 2 goes to 2, 3, 3, 4, 4, 5, 5, 6, 6. Once again, the X value did not repeat, so this guy is a function. 2, well, 1 goes to 1, so 1, 1. Then we got 1, 2, and 1, 3. So once again, the X value seems like it's repeating because, like I said, if you write this out with ordered pairs, you have this. And once again, we can see the X value is repeating, or the X value is associated with 3 different Y values. Same with our X value 5. He's going to 4, 5, and 6 for the Y value, so he is not a function. And here we got 1, 1, 2, 1, 3, 1. That's fine. Our domain member did not repeat, or each domain member is associated with only one Y member. 4, 5, 5, 5, 6, 5. So this guy is a function. So our function in the mapping diagram is 1 and 3. So B would be the correct answer choice in this case. Okay. Moving along. I hope y'all guys are getting this. Hopefully it's not too difficult. I never found it to be too difficult. All right, which graph represents Y as a function of X? Well, with graphs, it's easiest to do the vertical line test. And once again, vertical line test, I can draw an infinite amount of vertical lines. And I can see that if I even drew just one vertical line right here, I would hit my graph more than once. I hit it twice, actually. So he is not a function. And moving along. Well, once again, I can draw an infinite amount of vertical lines. And so, like, if I drew one here, it does not fail yet. But look, if I draw one here, he does fail. I actually hit this point right here, and this point drawing like a vertical line. So he fails the vertical line test, so he is not a function. H, once again, kind of with the circle. I'll just draw a vertical line right here. He'd fail the vertical line test there. I mean, he fell it right here as well. There's a lot of different places he fell. So he is not a function. Well, at least one answer choice, and hopefully this one is the function. But you know, if I draw a vertical line here, only hit it once. Same thing, hit it once, hit it once, hit it once, once again, once again. I'm drawing all these vertical lines. Doesn't no matter how many I draw, I'm only going to hit my graph once. So this guy is the function. All right, which representation does not show y as a function of x? So we're looking for the guy that's not a function. All right, we'll order pair 1, negative 6, 3, negative 18, 5, negative 30, and 7, negative 42. Once again, my domain members all go to one y member. Or once again, the x values do not repeat, so he is a function. Once again, we're looking for not the function. G, graph. Well, no matter how many vertical lines I draw, I'm not going to ever hit this guy more than once. So, let me just see. If I draw a vertical line here, I hit him once. Draw a vertical line here, I hit it once. No matter how many vertical lines I draw, I'm only going to hit my graph every once. So this guy is a function. And once again, we're looking for not the function. Okay, well, this time we got some ordered pairs here. 2 goes to negative 2. 3 goes to negative 2. 7 goes to negative 2. And 11 goes to negative 2. Once again, each domain member, or each x value, is associated with only one y value. So he is a function. And lastly, we got a mapping diagram. We see that 3 goes to 2, and 3 also goes to 6. So like, once again, if we brought this in ordered pairs, we would see that our domain member 3 is associated with two different y values. So he is not a function. Alright guys, that's it for the lesson. And I hope y'all learned something. Not just go back over this. Like I said, once you get the concept, this is pretty easy. Alright, well, y'all have a good day.